Welcome back, Night Owls. This is Dr. Nighttime, and tonight we are defending the honor of a fellow math YouTuber. A few months ago, a math YouTuber named VSauce2 released a video on what he called the wallet paradox. And a lot of people in the comments section said that they thought they had simple resolutions to this, and while there is a relatively simple resolution, they didn't understand why the situation seems paradoxical at all. And so tonight, what I'll do is I'll explain why it is that, yes, the paradox that this YouTuber VSauce2 was talking about, yeah, it really is a legitimate paradox, it has a resolution, but that he may have explained it a bit badly, but that, yeah, the simple solutions suggested in the comment section don't actually solve the problem. So, first let's describe what he calls the wallet game. So two people are chosen at random, and they reveal the contents of their wallets. If they're carrying the same amount of money, nothing happens. If they're carrying different amounts of money, the one with more money gives it all to the one with less money. Right? So, you want to be carrying less. Now the paradox is, do both players simultaneously have a financial advantage? And at first you say, no, that's not possible, right? And you'd be right. It's not possible for both players in a zero-sum game to have a financial advantage. But here's where the paradox comes in. There are three statements that all seem to be true, but cannot all be true at the same time. 1. The average payout for a randomly chosen player has to be 0, because it's a zero-sum game. 2. Because each game, other than the ties, right, which have no winners and no losers, the games that aren't ties have one winner and one loser, so the total number of winners and number of losers has to be the same. So the average modified win rate for a randomly chosen player has to be 50%. By modified win rate, I mean wins plus 1/2 of your ties. And then the third, this is the most complex one. Suppose you're carrying some amount of money. If you win this game, you'll always win more than that, right? Because you had to receive money from someone who had more, based on the rules of the wallet game. If you lose, you only lose exactly the amount that you're carrying. So, the expected money gained in a win is more than the expected money lost in a defeat. And so when you try to mesh those together, you're gonna win half the time, excluding all the ties, right? So of the non-ties, you're gonna win half the time. When you win, you'll win more than when you lose. So if that averages out, you should average out to gaining financially, but we seem to think that the average payout for a randomly chosen player should be 0 because it's a zero-sum game. So how do we resolve this? The trick is that the amount of money in a random person's wallet is not a fixed known quantity. A winner typically carries less than a loser does. If you were to ask, how much money do you think a person's carrying? You'd probably say around the average, right? When you then add in, and this person won this game, well now, because if two players have different amounts of money, the one with less is the one who wins, that would mean that the fact that you won would suggest you're carrying less money. So when we say you're winning more money than what you have, well, that amount you have is now less than what you thought it would have been. Or you now think it's less than what you thought it was. And if you win, and you say, so the amount that if you lose the match, so the amount of money you'll lose is the amount you're carrying, well, since losers of this game tend to carry more, now that increases it. And so that's what resolves the paradox. And if you do the math, on any given fixed probability distribution. That's how it'll resolve. I hope you found this useful. And as always, if you like the way I explain things and want to arrange private lessons, click the links in the description below. And until next time, this is Dr. Nighttime wishing you a good night.